Okay, so the next thing we're going to move on to is how to simulate the motion of the robot. So this assumes that you've got no warnings or errors. You have a simple script with some targets to follow, in this case, following along a curve, and you're ready to simulate. You must always simulate before sending motion to the robot so that we can avoid any unanticipated problems. Um, you might dip below the table, or you might start to move in a direction that might hit someone that's standing nearby, and so on. So there's a lot of reasons why you want to play this back. You'll notice that the last part of our script, step 6 and step 7, is first to simulate and then to send. So if we come in here, we'll realize that you can scrub the timeline and begin watching the um, the robot move. Now in this case, I haven't corrected the length of the tool, so my Rhino crashed earlier. So let's fix that. So we know it's not 304. It's going to be for the pointer something like 153 millimeters if we have a pointer tool on there. So let me go ahead and save this document. Um, that's really the only change I've made. So if we come back here, the other thing we can do is we can just play it back and watch it move from plane to plane. Because there's no rotation, this tool is not rotating. It's just moving along the curve. There's another way to set up these planes if you want them to align with the curvature, and then if you have a tool that has an orientation. And we can see here, because we have our end pose kind of tucked in, it did not come back to the same pose it had at the beginning. So before we had a 90-degree kind of setup with a T shape. In this case, we're just trying to tuck it out of the way. And I'll show you in another video how you can record the joint motions and then put them in here so that you can keep the robot kind of tucked away at the end of one of your workflows. Okay.